So Kristian, yes, please take it away. Saying fly an unsafe drone over Funen sounds interesting.
Right, so I'm a PhD student at the STU US Center, where I work on the health drone project. And yeah, one of the things I work on is safely flying unsafe drones. So to start off with a little bit of background on the health drone project, one of the things we try to work with here is that there seems to be a lag time in medical diagnoses due to slow transport of blood samples, for instance. So if you go to your doctor's office and you're ill, he may draw a blood sample, and this blood sample will then typically have to be sent to another facility for testing, for instance, one of the larger hospitals. So that means from the time the blood is drawn, you'll have to wait for the blood to be transported and then to arrive at the correct place and then be tested. And this lag time will cause patients to get more sick and maybe be administered more broad spectrum medicine. And this is in general obviously not nice to people, and it's also a great cost. So what we want to do is to create this network of direct on-demand aerial transport by autonomous drones of these blood samples. So instead of going by car, the blood samples will be transported by small electric drones, and this will bring down the transport time and therefore the time to diagnosis. By doing this, we may shorten people's hospital stay by getting their diagnosis quicker and maybe even keep them out of the hospital. And yeah, so this is what I'm working on, the technical side of getting these drones to fly. And when flying drones, typically you see someone standing with a transmitter and looking at the drone, and he's maybe taking pictures of a rooftop or something right above him. But when we fly out of the line of sight of the pilot, or maybe there is no pilot, then we talk beyond visual line of sight. And this is sort of the keyword in drones these days, because this is what most people want to do. But of course, if the drone is flying where no one can actively see it and control it, then that comes with more risk. And in drones, we have a risk assessment called a Specific Operations Risk Assessment, or SORA. And I'm not going to go through this. Klavs, who will speak after me, is the true expert on this part, but it can be boiled down to looking at the ground risk and the air risk. And the ground risk is basically the risk of harming someone on the ground. So you look at the population density of where you're flying, what is the risk of hitting someone should the drone crash, and the kinetic energy of your drone if it does hit someone. And the air risk is about airspace and where do you fly compared to where other aviation is happening. Are you in airspace where there's other planes, drones, etc. Now, when we look at the safety of these drones, they have some issues because drones came from the hobby, the world of the hobby stuff. So most of these components are still to a certain degree of hobby grade quality. Also, much of the software is community developed, which is a good thing and a bad thing. You have a lot of reviewers, but you also have a lot of cooks, and that is also a cause for error. So some of the main problematic components are the flight controller, the computer controlling the whole drone, the motors keeping the drone in the air, and the batteries. You can say basically one good thing about these batteries, and that is that they pack a lot of energy compared to their weight. But all other things you can say about batteries are bad because these lithium batteries, because they're very unstable. So there are a lot of things that can, given the chance, go wrong on a drone like this. This can of course be solved by redundancy, like we see in many other robots. You could have two flight controllers, maybe of different kinds, running different softwares, written in different languages, and being capable of taking over for each other. You can also have additional motors. So if one sets out, the drone can still maintain flight if it weighs less than what these remaining motors can lift. And you can have additional power sources. You can have more batteries, but they have to be added to completely different power grids, because if they're added to the same power grid, a short in one battery is a short in the system, and we're back to basically the start. Now this diagram is on purpose made ugly. It also saved me the time to make it pretty, but it shows the complexity of doing this. It is possible, but it's complex and it's also very costly. And testing this and proving that it works is also cumbersome and difficult. So we have decided to go another way, and that is to use the stop button. We know it from industrial robots, mobile robots. It's as old as the robot itself, and we want to use it in drones as well. Now, if you press this button on an industrial robot or a mobile robot, your dangerous situation stops here, and you can sort of recover from whatever happened. But if you stop a drone in the air, it is safe to say your situation is not over yet. Now you have a falling drone. So of course we have to add a parachute as well, so we can ensure that the drone falls in a safe manner. And by using the stop button, we can then say, okay, we know our drones are unreliable, we know they're unsafe, we know they're prone for things to go wrong, but we can at least ensure that this drone will not exit the area we are allowed to fly in, and it will not hit anyone with an energy high enough to potentially kill this person. And this is our way into basically being able to fly BVLOS. It's one of the issues, at least. So we made this reliable failsafe for an unreliable drone. And it's a system of two parts. We have a ground station unit and we have the aerial unit on the drone. And the ground station unit is what you can see here on the left image. And you see the red stop button. And with this box, we can see the remaining battery of the box itself, of the drone's failsafe system. We can see the GPS coordinates of the drone, its altitude, etc., because the failsafe system has its own GPS as well. So that means if all communication to the drone from the ground computer is lost, we still know where it is due to this box. On the drone, it's communicating with the part there, and it's on a completely different radio frequency than the rest of the drone. It's also a completely different system. It has its own battery, and the only place where it intercepts with the drone itself is the motor signals going from the flight computer to the drone's motors. So in case you press the button, it'll cut the motor signal to the motors, stop the motors, the drone will start falling, and a parachute is deployed. Now, some research has been made that the impact of a falling drone has to be less than 50 joules to avoid potential death. So of course we have to have a large enough parachute, and we have tested this system to work also at a range of 150% of the normal operating range to ensure that at all times when this drone is flying, we have the connection with it through this failsafe box. So right now we are flying beyond visual line of sight out at the Kristian Andersen airport north of Odense. And we're flying closed airspace. So that means when we fly, we close down the airspace for all other aviation. And that is of course because we are still in the testing phase of this, and we have no way to see these airplanes at the moment. The thing is, most airplanes fly around with a transponder, but it's not mandatory for small hobby aircraft to have these. So if we go across Denmark, we may run into gliders and small Cessnas, etc., that we cannot see because they have no transponder. And that creates an air risk, which our parachute system cannot handle. So now that we can bring the drone down at exactly the time we want it to, then one of the next things we need to look at is how we integrate our drones into the airspace. And that means drones being able to see airplanes and general aviation, and it means general aviation being able to see drones and drones seeing other drones. Now, this is where something which has been in the media a lot lately, UTM, comes into the picture, which is traffic management for drones. It will be the same as for aerial, regular aerial traffic management, where we have the system which creates awareness, and it has to be integrated with the one for regular aviation. And once we get this, it will be possible to really set the drones loose and actually get drones flying across Denmark, solving logistics tasks and further developing this technology. And yeah, I can see that is basically it. I can see I'm a little fast, but we're a little late, so I guess it sums up well.
Yeah, that's great. I have a question though.
Of course.
So one thing is bringing the drone down, I guess, but another thing is also where it comes down. So I mean, maybe the limitation you said of, was it 50 joules? to avoid death is if a person is hit, I reckon, in the head with a drone. But what if it lands in the middle of the motorway?
That is, of course, also an issue. And as soon as you eject this parachute, you have no control of where it lands. So part of this, when we do these long distance flights, will also be designated corridors for flying, which will not follow the highway, for instance. Also, many things can go wrong on the drone. It may actually be able to sustain flight just a little longer, and we can go to a rally point, which will be in the middle of a field, previously identified as a safe place. But it's mainly flying away from these structures and infrastructure that we know is unsafe.
Another question. A drone typically picks up a lot of information, so there's a lot of actuators, IMUs, and you can see the current going to the engines and such. Which of these information streams do you listen on for deploying the parachute?
So at the moment, the system is completely manual. So that means we observe the drone as it's flying on our computer, and we can see whether it maintains altitude and flies where we want it to. If it doesn't, we stop by hitting the button. Okay. Which you haven't had to do in an actual hot situation yet. We have only tested. But of course, one of the things which will be added is to use this IMU so that we know if the drone is facing the right way. If it's suddenly upside down, we know something's wrong and how to deploy it. Also to interface with the rest of the telemetry data and knowing if the batteries are okay and stuff. So it'll be, in the beginning, it'll just be the IMU, and then later it'll be basically all the data that's relevant, battery, temperature, etc. Okay.
Thanks. Other questions for Kristian before we switch to Klavs? No? Okay, thanks, Kristian.
Thank you.
Klavs, feel free to share your screen when you're ready.
Okay, I will try. So now you should be seeing my screen, right?
Yes.
Okay, so I am Klavs Andersen. I am an independent consultant since last summer, where I left the Danish Civil Aviation Administration, where I was working with drone regulation, both nationally and internationally, in terms of EU regulation, but also in the worldwide organization called JARAS, in which we draft a lot of recommended practices for drone regulation, and I'm still participating in much of this international work. So I'm going to give you a short introduction to what the recent developments in the regulation is, and the things that I'm going to cover in this presentation is the EU drone regulation, which is already fully drafted, published, and will actually apply from New Year's. And I will, once I have talked about this, talk a little bit about what does this mean specifically for BVLOS operations. And then the second part of the regulation that is still coming is the airspace, or UTM, if you will, regulation. I will talk a little bit about what we expect that to be and what that might mean for the future of BVLOS operations. I do make use of some EASA slides, so those are courtesy EASA, but that of course means that when I use an EASA slide, I cannot possibly talk incorrectly about what EASA wants to convey with these slides. So if we take a look at the regulation, which is now due to come into applicability of 31 December this year, this is a big overview of the principle behind this regulation. It is operation-centric and risk-based. And by this means, we mean that we have a regulation which takes into account what is the risk of the operations we want to regulate, and divide that into three categories. The low risk category, which is called the open, the green category, is low risk operations where by simple means such as reading the manual, have passed an online test and having a drone that may be CE marked, the assumption is that this operation can take place without any further authorization from any authority and still be safe. If we go to the middle category, that's called the specific category. This is where we have an increased risk in the operation, and therefore we want to have some authorization to govern what can be done and what cannot be done before the operation actually commences. So this is an increased risk category. And then to the right, we have the highest risk category. We call that the certified category, and that is really equivalent to what we call manned aviation today, where manned aviation for both small GA aircraft and of course passenger aircraft are governed by certification rules, both of the aircraft, the person who operates the aircraft, and the operation itself. So the certified category, think of this as similar to manned aviation. As I said, we have the regulation which was due to apply from July 1st this year, but it has been delayed until New Year's because there is some hefty implementation work required for the member states. And due to the COVID crisis, the member state needed more time to actually implement those things nationally. And therefore we now expect it to apply from New Year's. The certified category, as you can see, we do not have any regulation yet. So work is still ongoing on drafting regulation for this category, and we expect to see the first draft regulation by the end of this year. If we take a look at the two lower categories, firstly the open category, this is quite similar to what almost all countries have all implemented in one way or the other. That's all visual line of sight operations, and it is with drones that have a maximum weight of 25 kilos. Even though it's similar to what the nations have, there are some changes, some minor changes. And I'll try and highlight those. The first interesting change is that we now for the first time see regulation which allows operation over people who are not part of the operation. So you can overfly people while doing your operation. And secondly, if you look out to the right in this column, you can see that the competences we require from the remote pilots are something like having read the manual, may have passed an online test, which at least compared to Denmark is less stringent than what we have now. Because today in Denmark, you need to go to a 2 or 3 day course and you need to pass a theoretical exam and in some cases also a practical exam. So there are some things that become easier in the new open category compared to what you can today. And how is that achieved? What is the argument that we can lessen the requirements on these operations? The most important change is that you see we have 3 different subclasses of operations, A1, A2, and A3. And you have to have a drone that is compliant with requirements for each of those categories. Those requirements are called C0 to C4. And those are technical requirements that the drones have to meet. That is actually a CE mark requirement, so that you can only operate in the A1 category, either with a privately built drone of no more than 250 grams, or a drone that is not privately built up to 900 grams that is compliant with either a C0 or a C1 CE marking category. So there are some lessening of the burden for the operator, but the other side of the equation is that the manufacturers of the drone need to supply CE marked drones. And this is just highlighted here, that in the regulation that will now apply from New Year's, there's actually stipulated technical requirements for these drones in C0 to C4 that they have to comply with, and they have to demonstrate the compliance, just like any other product you buy, which is has to have a CE marking. And this CE marking that we're talking about here is then, of course, specifically for drones. So the requirements are specific for drones. So that's a new thing. And it is, of course, not possible today to buy a drone that is CE marked. So there is a transition period from when this regulation apply and the CE marking will really become possible for the manufacturers until 3 years from New Year's, when you have to have the CE marked drones. If we then move to the next category, the specific category, the overall definition of specific is if you cannot perform your operation in open category, you are automatically bumped to the specific category. And there's no option of getting a waiver, a dispensation, or whatever you would call it, in the open category. If you cannot comply with the requirements that I showed you in the table and all the underlying text, you are automatically bumped to the specific category and you have to operate in this category. And typical examples of specific operations is BVLOS. It's drones that weigh more than 25 kilos. Or it could be that in the urban case, you would want to operate a drone that is more than 4 kilos. Then you are up in the specific category. To operate in the specific category, the basic underlying requirement is that each operation has an inherent risk that needs to be assessed. Cannot operate in specific unless there has been a risk assessment. Kristian already talked about the SORA. The SORA is a risk assessment tool that was developed in GIROS, the organization that has worldwide participation by authorities. And it is, if you will, a cookbook where you take in what is it you want to do in terms of a concept of operation, a CONOPS. What kind of area are you overflying? Is it over an area that is fenced where there's absolutely no third parties, so the risk to third party is very low? Or is it in the other sense, is it above a football stadium filled with spectators for the football match? So what are the risks to people on the ground? What is the risk to other airspace users? And what are the conditions that you are going to operate under? And what is the drone that you actually are going to operate under? All this is fed into this cookbook, and the model will tell you how risky is the operation that you are actually going to perform. And the risk is assigned a SAIL, a specific assurance and integrity level, and the higher the SAIL number, the higher the risk of the operation that you are going to perform. And once you have completed this, there will be mitigations implied that you have to comply with in order to get an authorization for your operation. So risk assessment is key in a specific category. And if there is no risk assessment, there is no way to get an authorization. There are some ways where you can shortcut somewhat the process of the risk assessment. You can make use of what others have already used, etc. But somewhere there has to be a risk assessment for the operation in question. And if we specifically want to look at what does this mean for BVLOS operations. So the regulation and the SORA method addresses BVLOS, and that is new compared to previous regulation, at least what we had in Denmark. We knew that you could not do BVLOS unless you did something extra, but we could not really identify what was this extra mitigation. Now, this is what the regulation states, and it states that you have to comply with SORA. And especially for the air risk mitigation, this is where we have been lacking. What is the mitigations that make an operation safe? And the SORA prescribes how to mitigate this. And one of the key things that the SORA says is if there is a risk to hit other traffic, manned traffic, then you have to have an detect and avoid function. So you have to be able to detect other traffic, and you have to be able to steer away and avoid hitting them. This function can either be on board or it can be provided off board. The SOAR does not prescribe actual methods, it only describes the safety principles that you need to comply with. However, if we look at BVLOS and detect and avoid, this has been pursued for many years in developing technical solutions that can see manned aircraft and make sure you see them in time so that the drone does not hit them. But you know, this technical challenge has been much more difficult to solve than we maybe thought about 10, 20 years ago. And so right now, such onboard systems really only exist for the large military type drones. So this is where the last piece of the regulation that I'm going to talk about comes into play. Because this is what we can, this detect and avoid function we can partly get from a UTM or / use-based system. UTM is the worldwide designation for unmanned traffic management, and use-based is the term that we use specifically in the EU, but it covers the same functions. And so we now are in a situation where we will not see widespread BVLOS operations until we have a UTM or a use-based implemented. There will be some. We can do it in segregated airspace. That's airspace where there will be no other manned operations. We can maybe do other tricks to mitigate some of the air risk, but this idea of going anywhere at any height with any drone with any payload across the country, BVLOS, we will not see that happening until we have UTM or use-based implemented. So this is the last part of my regulation overview, is because this will cover the use-based regulation that is currently underway. So what is use-based? Well, use-based is a set of services that will be provided in an airspace in which we think we need use-based to enable the US operations to be conducted in a safe and efficient manner. And it is key to the growth of BVLOS operations. Until we have use-based, as I said, we're not going to see any significant growth in the BVLOS operations. And of course, it's also necessary to have use-based to make sure that we can have lots of drones in the same airspace, but conducting different BVLOS operations, because there's also a collision risk drone on drone, which we need to mitigate. And then finally, of course, from an EU perspective, if by having it as an EU-based regulation, then it'll mean that we harmonize across the EU. And when we say use-based, we also talk about airspace. So one of the foundations of this regulation coming is that the member states will decide, where do we want use-based? Where do we want to establish airspace in which we implement the use-based and thereby enable typically BVLOS operations? And to the right, you see an example of what that might be. That's the test areas that we have around Kristian Terkildsen Airport. So that could be an example of actually existing airspace already kind of reserved for drone operations, that we say this now become a use-based area, and we enable and we provide these technical services that makes it possible to have more widespread BVLOS operations. Where are we with use-based? Well, the EU and EASA has worked on use-based for some years, so we have known for some time that we need it. There's been a lot of funding poured into use-based to make demonstrations, to get a better understanding of what is use-based, what does it need to be, how should we do it, what are the technical solutions, what are the procedures, what works well, what does not work well. And that has kind of been feeding the regulation drafting process, so that we get regulation that fits with what we need and what we can build. We have a proposal on the table now. You can see a published link here from early this year. There has since been new versions of this regulation drafted and circulated to the member states, and they are sitting as we speak and doing the final negotiations to agree on this piece of regulation. And we hope that it'll be complete by late 2020. So that means that the EU Commission and the Parliament says, yes, this is now something we want to make law. And we expect that it might have a 1-year transition period. So that means that from late 2021, it could actually start apply, meaning you can actually then operate, or you are obliged to operate in accordance with the use-based regulation when you want to do use-based. This is all still flexible. I haven't had an update for the last couple of months, so whether the timeline will stick, we'll see, but that's at least the goal. Here, a slightly busy slide to give you an impression of what use-based is in terms of integration between manned and unmanned operations. You see 2 green bubbles here. One is what we call uncontrolled airspace, and then you have another one called controlled airspace. But if you just look at the uncontrolled airspace, imagine the airspace you saw on one of my previous slides. This is now within these boxes that you saw around Hans Kristian Andersen Airport. We have designated that use space, and you can see that manned aircraft will talk to something called FIS, Flight Information Services. There will be a coordination between the Flight Information Services and the use-based system, which is here called USSP, so the service provider. And the service provider, the USSP, will communicate with the unmanned aircraft. So this is a set of coordination procedures, it's a set of services, it's a set of communication that allows the operations to take place in a safe manner, in a coordinated manner, where we all know where we are, what we're doing, and what can be done and what cannot be done in this piece of airspace. So that's, if you will, the overall concept of how we see use-based implemented. A little bit more about what these use-based services actually are that should enable the BVLOS and the safe integration with manned aircraft. So in the blue box, you have 4 services which the draft regulation says you have to have when you provide use-based services to the use-based US operator. So you have to have some network identification service. That means that you can, the drone has to transmit an ID so we know who they are, and that has to be picked up by the system so that once the system reports back to other users and to the flight information service, they can say, well, this drone, the number such and such is here and here, and we know who they are. There is a geo-awareness service, which is helping the operator, the drone operator, telling him where is he actually allowed to fly and where is he not allowed to fly. There's a traffic information service, which gives information about where is other traffic so that we can avoid the traffic. And finally, there is a flight authorization service, which is something you use prior to the operation. You actually apply for authorization to perform your operation in this use-based area, and the service will come back and tell whether you can get an authorization or whether you need to modify or whether you are not allowed at all to operate. And so these are use-based services that are required as it looks right now, and there will be more coming online in the future and identified in the regulation as it's being updated. There are a couple of supporting services, which is
Klavs, sorry, I was apparently muted when I said something. We're right about out of time now, so yeah. I think you should have your closing comments now.
Okay, will do. That's appropriate because this is my summary slide. Just in summary of what I've been talking about, the EU regulation, which will provide, which will apply from New Year's, will set the stage for BVLOS operations. However, as I talked about, the air risk mitigation for BVLOS is not really in place. That is what the use-based will provide. And we are expecting to see the use-based regulation late this year and apply from late 2021. And then subsequently, once we have the regulation, we need to see the use-based system actually being developed and implemented So that's something you had to add on in time. And people always ask, what time should we expect? And it's very, very, very difficult to answer. But if you think in terms of 5 years as when nations have implemented use-based across their nation, that is not, that's a ballpark figure to go by.
Okay, thanks, Klavs. Very interesting and thorough go through of current developments on drone regulations. So thanks for that. Our next speaker is Dimitris from Aalborg University. He will talk about aerial firefighting. So Dimitris, when you're ready.
Yes, hello everyone. I will share my screen and hopefully this will play nice.
Yes,
I guess you can see a big Robotto thing. So hello everyone. I just, as a small note, that it was originally Kenny, the CEO of Robotto, to present today, but they just delivered a child yesterday, so they couldn't really be today. So I'm filling up his shoes, and hopefully I will do it in a good way. So welcome to this presentation. My name is Dimitris Chrysostomou, and I will present what Robotto does in the area of aerial firefighting innovation. And as you already know, wildfires, it's a critical hazard, right? I mean, we have seen the news, it's all over the world. It's in Australia in the beginning of the year. Here in the video, for example, I want to demonstrate how devastating a wildfire can be, because it's basically a video where in basically 3 minutes, you will see that there is a wildfire coming from the forest and then basically destroys everything in its passing. And we basically seeing all over the news and all over continents and countries how devastating effects the wildfires have in climate change, and we can see, for example, now the severity of such wildfires. I hope the video plays okay. So you can understand that being in that situation, for example, you need lots of information, right? I mean, you need to be able to understand how to protect yourself from that aspect, especially if you're a firefighter, and at the same time, where to go when something like this happens. And this is where Robotto comes in. And I think this video is actually heartbreaking to see that in 2 minutes, everything is pretty destroyed. So basically by skipping it, you can see that that's not really easy to do something about it. So basically, as I discussed before, we saw in the news that Australia, for example, had more than 80 million hectares burned out due to the wildfires. They had more than 430 million tons of CO2 in the atmosphere, and billions of dollars spent in firefighting and dealing with damages and fatalities of people, of animals, of people losing their houses. The same happened recently in the United States, where they had 10,000 simultaneous lightning strikes in 600 sites. They caused one of the worst fires in the state's history. For example, in 7,000 fires were happening just in 1 month. So we have seen all over the news. Also in Amazon, in South America, we have seen that more than 90,000 fires have happened through the last season. And also actually here in Europe as well. I'm coming originally from Greece, so every year we have to fight with firefighters, and even in places that we don't expect that we will have this kind of destruction, like Sweden, they had to deal with more than 30 billion US dollars of damages. But when it comes down to tackling this problem, of course, as we said before, information is key, and firefighters need to really be able to address this destruction by using most likely airplanes, as it's commonly used right now, where airplanes are really resource heavy, they're very time consuming, and they mostly focus on taking off the fire, not just predicting where it's supposed to go, or not informing the firefighters where they're supposed to do something. At the same time, we have helicopters, of course, which are also highly costly, and it's a manual and a heavy labor, repetitive task that needs high training. At the same time, we have seen a lot of satellites being into the play, where they're time consuming, and most of the time, if we have a lot of smoke and a lot of clouds, they're not really be able to be used. And this is where in Robotto, we thought about drones, for example, that we can deploy them fast. They're very easy to access, let's say hard to reach areas. At the same time, we always need someone that is a trained pilot, manually controlling the drone, and at the same time, getting all this data, for example, and manually processing, it's a lot of work. So in the future, we believe that artificial intelligence and fixed-wing drones, for example, is the answer. That especially autonomous processing and autonomous flight and navigation view on top of a fire, it's one of the best options we have available. At the same time, we can deliver fastly the data, and we hope for high accuracy due to AI processes. At the same time, with fixed-wing drones, we can cover vast areas with higher endurance and a better communication range than we can get with a simple drone. So where Robotto comes in? Robotto basically it's a growing startup. It's a spin-off of Aalborg University that is really committed on finding innovative and sustainable ways of fighting wildfires. How they do it there, and I will go into details later. It's by utilizing AI and robotic technologies to support the communities and give as much support as possible to the firefighters right now. As you can see here, it's right now leading the field in terms of national efforts on helping the firefighters. It's also keeping a responsible and ethical approach that we all know that how AI is so powerful, but at the same time, try to use it in the right way that it doesn't give a lot of concerns. And at the same time, it's trying to also help with firefighters, but by using AI, tackling multiple other use cases. So the strongest tool in Robotto's tool case, let's say it's what we call Aura, which is an autonomous wildfire and eco-sense platform, which enables firefighters to monitor fires in real time, with, as a result, reducing firefight fatalities and really have a highlight on operators' safety. At the same time, we have seen that it's easier to allocate resources while being in the real-time case. You can deploy firefighters in the right place at the right time. And the best tool we can give to the firefighters is that they can predict where the fire will go by keep tracking the fire from the air and getting the data up to a handheld device that a firefighter can have. Let's dig a little bit deeper on how actually it works. As you can imagine, emergency services arrive first thing in the fire, and they scout around for possible information they can use for the severity of the fire and how to know more about the specific case and what do they have to tackle with. This is where the drone operator selects an area of interest. We already know that most of the emergency services, they have at least one drone, skilled drone operator. So it's not some random firefighter that does this job, it's someone that's already a trained pilot. In case, let's say, the autonomous functionality fails and has to take over manually. But the way this works is that the drone operator selects an area of interest in the handheld device, mostly a tablet, and then the drone automatically goes in the air and starts searching for the desired area of interest. And whenever the fire is detected, then gives back to the operator the location, the size of the fire, the direction, and the prediction of the direction where it's supposed to go. And what makes it truly different, because most of the time we hear of drones being able to be controlled from people and more or less using the sensors on board and getting this kind of data. The main difference here is that it's an autonomous system. It's not fully autonomous, but it's still an autonomous system where the moment you give the area of interest, then the drone can take over the rest. The detection is done based on a state-of-the-art neural network that it's uniquely designed for that specific purpose. And it's based on multimodal data, for example, RGB images that come from the onboard camera, images from the thermal camera as well, plus all the temperatures and all the different shapes of the flame and the shapes of the contours of the area that expands and also smoke. At the same time, it provides an accurate geolocation, which is based on the onboard laser finder plus some perspective transformation calculation that does on board while using the cameras of the drone. And the most important aspect, according to what we believe is the most important one, is the edge computing. So in case you don't really have internet, very good connection of internet, let's say in the middle of nowhere, in the middle of the forest, then at least we can still operate in a closed network and give back some feedback from the cameras and from the thermal cameras, so the firefighters can continue doing that.
Dimitris, we have a question from Ulrich.
Yes, of course.
So Ulrich, you can just unmute and ask yourself.
Yes, I was looking forward for a question from Ulrich, actually.
Yeah, no, it was just maybe the standard AI question is that AI is wonderful, but is it safe? Like it could make predictions that make no sense from a human logical point of view and that are incorrect even. So how do we, in the spirit of safety, how do we trust it here? I mean, at the same time, I mean, we thank you for doing work like this. I really like it. But can we trust the AI?
Yeah, actually, let me show you this video because this is exactly how it shows a little bit how it operates, and then after that we can actually continue with this. Thanks. Because I think it fits nicely with actually looking at the video first. And this is something that we had an operation just 2 weeks ago in the western part of Denmark, and this is basically again, if I will skip him a little bit, maybe where we go directly to. For example, that's the idea that drone goes in the sky and already the operator has shown the area of interest. I think I have to skip somewhere here. And that's actually the fire that was going on. It was a controlled fire. Basically, they wanted to burn some specific area for nature control. And this here you can actually see that it's using the infrared, thermal, and the actual RGB in order to predict where the actual fire was and detect where the fire was and actually predict where it's supposed to go. So you can actually see that it goes around the area here and predicts that we expect according to the smoke and according to the direction of the wind where it's supposed to go. So in order to answer to you, Rick, if it's completely safe, we believe it is. It gives 90% accuracy of where the fire actually went afterwards when we evaluated the site. If it will work while having strong, let's say, winds and I don't know, crazy conditions in an actual forest, we haven't tested in a fully operational mode. We haven't tested in an actual, let's say, California fire, right, where things going crazy, maybe more lightning strikes are happening. This is something that it's part of the process that the best we can do right now is having controlled fires, going in the sky and being able to say, okay, where do we believe this will expand, and then evaluating that this will expand over it is. In simulation, the neural network at least works pretty good. It can get quite high accuracy of detecting where it's fire, where some tracks, where it's more of a smoke or just a cloud, for example. So it can actually detect accordingly and give the right navigation command to the drone. But of course, yes, you have a point there that we haven't tested in an actual, big wildfire that we have to really be careful there. In terms of following all the standards, we do follow all the standards in terms of flights and in terms of how to deploy the artificial intelligence code on that. And this is also part of some of the next slides. And basically where we're looking that we can continue on the future here is that drones are nice, but as we said, fixed wing drones will be even better because then we have a much bigger operational radius and quite a longer flight time. At the same time, the altitude can be higher, plus that we can actually store much more equipment on the actual drone and get better performance. And as I said in the beginning, we're normally using this in a lot of other use cases. We normally get a lot of calls for other sort of emergency services like search and rescue, people that fall into the fjord, for example, or we need to do some kind of aerial inspection on wind turbines or bridges and so on. And at the same time for animal control, by tracking specific species and see where they can actually go. Right now, so far we have...
Dimitris, can I ask a question?
Of course.
Going back to actually what Ulrich was talking about. So you're operating with a neural network. I was wondering how you trained this network, or is it something that you sort of got off the shelf?
No, we started by having something off the shelf. and it's based on a mobile network. But at the same time, we do what is already available out there. We also publish the results later in some scientific applications in IEEE and Springer now. But we took that and we tailored to actually getting the amount of data we have and the kind of fires that we have in Denmark and in Europe to begin with. And then from there, we keep either simulating the performance and then putting it in the real using control fires and then getting actual data, because most of the times the kind of data you can find online, it's, you know, these kind of huge wildfires that they're burning everything in a matter of seconds, while the wildfires that we're currently tackling and the ones we're expecting to tackle in the future, it's better when we have our own data that we can train the neural network to predict even more and in a better way where the fire is supposed to go.
Okay, thanks.
Great.
4 more minutes, just so you know.
Yeah, I only have 2-3 slides left. So basically, as I was saying before, we're mostly working on local and national authorities. As I said, also we have many of control fires that we're looking at, and we really want to expand in actual wildfires, which is also a little bit weird thing to say that we expect to have a real wildfire in order to test the platform, but at the same time we're trying to make this as accurate as possible. And we are part of 2 pilot programs right now in Sydney, in Australia, and at the same time in Barcelona, where we're working closely with emergency services and operators that have vast experience on tackling these operations, and especially getting their feedback in improving the GUI on the tablet and how the drone can fly and so on. And for my sake, if as a variable message, for example, of this presentation, I would like you to keep 2 aspects that they are very key pillars of Robotto with this product, is that sustainable and ethical solutions, right? I mean, we really want to facilitate the appropriate management of all the natural resources and preserve as much as biodiversity as possible, and at the same time create solutions that they lead in more sustainable society. And at the same time, we keep getting a lot of questions on, as Ulrich said, for example, that what about the AI? Of course, it's a quite powerful tool for application. And we believe that by using it as transparently as possible and by giving all the code available in GitHubs and repositories, that it's possible to ensure solutions that they are safe, transparent, and we target key applications in multiple other areas. So that will be for me. By all means, feel free to follow Robotto in all kind of social media and the webpage, and ask me any questions you would like to have.
All right, thanks, Dimitris.